Okay, for part 2 of your KIN 225 lecture for Wednesday, February 3rd, we're going to be talking about the force-muscle length relationship. And this has some implications for how you train in the weight room. So the force-muscle length relationship. Muscle force varies with the length of the muscle. So as you go through your range of movement, you're weaker at some points in your range of movement than others. And this variation in force from a physiological perspective is due to variation in actin-myosin overlap. So this is the force muscle length curve. So you can see that as you move through your range of motion from a short muscle length to a longer muscle length, your optimal force development is somewhere in the middle. So a good example is something like a biceps curl, and that's what I have here, is you're relatively weak at the start of your range of motion, so at the bottom of the biceps curl, and then about halfway through your at your maximal strength, so your muscle is actually stronger about halfway through. Then when you get to those short muscle lengths, you get weaker again. And the reason for that is, again, because of the way that actin and myosin overlap throughout your range of motion. So these letters, A, B, and C, correspond to these points on the graph, A, B, and C. And these dark lines represent actin, and then this thick green line represents myosin, with the myosin heads that would interact with the actin. So at your really long muscle lengths, the problem is that your actin is pulled out too far. So these are your Z discs here. So your sarcomere is too long, and your actins don't form optimal overlap with the myosin heads. About at the midpoint of your contraction, you're the strongest, and that corresponds to B over here because you have optimal actin-myosin overlap. And then out at C, where your muscle length is shorter again, the problem here is that the actins get scrunched together, so that interferes with the overlap with myosin. So again, you're weaker at that short part of your range of motion. So this applies nicely to a lot of the single joint exercises, such as the biceps. So what I mean by single joint exercises is that your movement is only at one joint. So with something like the biceps curl, the movement is only at the elbow joint. So here with the movement at one joint, you're really looking at only one set of muscles. So here you're just looking at the elbow flexors. Different weight training machines have been designed to accommodate this change in your ability to generate force throughout your range of motion. So a classic example is the Nautilus cam system. And you'll see this cam system on a variety of machines, including a lot of the machines down in the pack. So you notice that the cam system, it uses this weird looking pulley system, where it's not like a round pulley, but it's more of an ellipse. You get a better picture of it here. This is the cam pulley. So, you know, the cable or the chain goes around here instead of just around a single tiny pulley. So you get this alteration in the moment arm when you're lifting the weights. It's got to do more with biomechanics. But what this does is it makes the movement easier at the start of your range of motion where you're weakest, and then makes it more difficult in the middle of the range of motion where you're strongest, and then makes it easier again at the short muscle lengths where you're weaker again. So this type of pulley system is designed to alter the amount of force that's experienced by your muscle throughout a range of motion. So for example, with something like the biceps, it makes it easy at the start of the biceps curl where you're the weakest. It makes it more difficult in the middle of the range of motion where you're strongest, and then it makes it easier again at the end of the range of motion. So it's attempting to match this force curve that you have. And the Nautilus system is named after this, apparently after this seashell, which is called a nautilus. Now, when you do something like a multi-joint exercise like the squat or bench press, so the squat involves movement at your ankle joints, your knee, and your hip, and to a degree, your back as well. That messes up this traditional force velocity curve. So with a squat exercise, with all those joints involved and all the different muscle groups involved, you end up getting a curve that looks something like this. So you're essentially weakest at the start of your range of motion when you're down in the squat. And then as you move throughout the range of motion to the standing portion, you get stronger. And you see the same thing with the bench press. So bench press involves movement at your shoulders and your elbows. So it's a multi-joint movement. And again, because there's so many muscle groups involved, that it kind of messes up this force muscle length curve. But it looks a lot like the squat curve. So you're weakest at the starting point in your range of motion, and then you get stronger as you go out through your range of motion. So a challenge here is in the weight room, how can you match your lifting performance for how weak or strong you are throughout the range of motion. So what you want to do is you want to make the exercise easier at the start of your range of motion, but you want to make it more difficult as you go through your whole range of motion, because you're stronger, and that would give your muscle an optimal training effect, because you're providing overload according to your strength curve of your muscle. So you want this movement to be easier at the start, and then as you move through the range of motion, you want to make it more difficult. And a way to accomplish that with these multi-joint exercises, and this is an example of the squat movement, is by using elastic resistance bands. So you'll see in this video, this trainer is he's got this thick elastic band with handles on it, and he's going to be doing a squat exercise using the elastic band. So remember that you're weakest at the start of your range of motion when you're in the squatting position, and then your muscles are stronger as you move throughout the range of motion. So you want the exercise to be easy at the squat position, and then you want it to become more and more difficult as you move up through your range of motion in order to match the strength of your muscle. So down in the squat with the elastic band, at the bottom of the squat, that's where you're weakest, and this is where the exercise will actually have the least resistance, because there's more slack in that elastic tubing. So at the weakest point in the range of motion, there's the lowest resistance provided by that elastic tubing. And then as you move throughout the range of motion to the top, you're getting stronger throughout the range of motion. And what's happening is the elastic band is becoming tighter, and so it's providing more resistance at your stronger points in your range of motion. So as he moves through the top, he's getting stronger as he moves throughout that squat movement, and that elastic band is stretching, so it's giving resistance to his muscle as he moves throughout the range of motion. So this is an example of how you can match an exercise to those the different points in your range of motion where you're stronger or weaker. And this is just an example of the same thing with the bench press. So again, with the bench press, you're weak when you're at the start of your range of motion, and then you get stronger throughout the range of motion. So you can see in this example, they've got these giant elastic bands tied to the ends of the barbell along with a heavy weight, and then those bands are secured to the floor. I've seen some people in the weight room, they'll take an elastic tubing and they'll just put it under the bench and bring it up the other side and tie it to the barbell. So they do it that way instead. So again, you're weakest at the starting point in your range of motion, so the lowest point, and then you get stronger as you push throughout the range of motion. So again, at the starting point, the elastic band is taken up and it's easier. And then as he pushes through the range of motion where he's getting stronger, the elastic band gets longer and longer and provides more resistance and matches the strength of the person's muscle as they're pushing through that bench press. Again, there's some machines that take advantage of this. So something like this is called the SoloFlex machine. I'm not sure if they sell this anymore, but this was a home piece of home fitness equipment. You can see that it uses elastic bands as resistance. And so for something like the squat or the bench press, this would actually provide a pretty good resistance, because again, when the elastic band is taken up, it's at the bottom of the range of motion and it would make it easier. And then as you move throughout your range of motion, the elastic band becomes more and more stretched and provides more and more resistance, which matches your strength throughout that range of motion. The Bowflex machine does the same thing, except it uses these rods. So the deal here is with the bench press, at the start of the range of motion, the rod would be bent up here and providing less resistance. And as he pushes out with that bench press, it's bending the rod, and it bends it, as it bends, it's providing more and more resistance. So again, it's matching that strength throughout the different points in the range of motion. Makes it easier at the start of the range of motion, makes it more difficult out here where you're stronger. So again, it just provides a better overload to your muscles throughout the whole range of motion, provides a greater training effect. And this is the Bowflex. Again, you can see the rods here tied to the cables, and this person is going to be demonstrating a squat on the Bowflex. Again, with the squat, you're going to be weakest when you're down in the squat, and you're going to be strongest as you move up through your range of motion. So you'll notice with the Bowflex machine here, when he's at the bottom of the squat, the rods are relatively straight. So here he goes to the bottom of the squat. And you can see the rods are straighter, and then as he moves up through the range of motion, the rods become more flexed, and that more flexed, as they become more flexed, they're offering more resistance. So at the bottom of the range of motion, the rods are offering less resistance, and then as he moves up through the range of motion, the rods are offering more resistance as they get more bent. So again, it's just a machine that's designed to accommodate the different amounts of strength you have at the different points in your range of motion. And I've got those videos linked to you with these YouTube links that I posted. And I found this cartoon, you know, and I don't think the person that made the cartoon was thinking about this, but with the elasticity of the person's undershirt here while they're lifting the weight, it's actually going to be providing that accommodating resistance. So at the bottom of the person's range of motion, in this case in the shoulder press, they're going to be weakest, and then as they move through the range of motion, they're going to get stronger, and that elasticity of his undershirt is actually providing more resistance as he moves through the stronger points in his range of motion. So again, a cartoon that I think unintentionally shows that you know, you can use accommodating resistance to accommodate the differences in strength that you have throughout your range of motion by using elastics.